In this section, we will look at third order linear differential equations. Now, we've mainly studied first order and second order linear differential equations. A third order equation has a similar form. You have a function of x times y triple prime plus a function of x times y double prime plus a function of x times y prime plus a function of x times y equals a function of x. So any equation of this form will be a third order linear equation. So y is a function of x as well. Y prime is dy by dx, y double prime is d squared y over dx squared. And the main thing is that these coefficients that appear with the derivatives or with y, they should not have y in them. They should be either constants or they should be functions of x, because any constant can also be treated as a function of x. And similarly, the right-hand side in this form should be free of y. It can be a constant or it needs to be a function of x. So now we have solved a lot of second order equations of this form. So this is a third order. And if y, so in this case, the homogeneous equation is defined similarly. If this right side is 0, then this is homogeneous. So if y1, y2, y3 are the independent or fundamental solutions of the associated homogeneous equation. So remember, we had in second order equations, the homogeneous equation had 3 kinds of solutions. You could, if the roots were different, the solutions were c1 e to the rt plus c1 e to the r1t plus c2 e to the r2t. In this case, e to the r1t and e to the r2t would be the fundamental solutions. Similarly for the other 2 cases. And so if y1, y2, y3 are the 3 fundamental solutions, in this case, since it's a third order equation, so the homogeneous equation will have 3 fundamental solutions. And yp is a particular solution. So particular solution is again the same as it was defined in case of second order equations. Then every solution has the form particular solution plus ay1 plus by2 plus cy3. And this is just exactly the same as we had in case of second order equations. We're just adding one more dimension. So in that case, it was the particular solution plus ay1 plus by2. And now we also have a cy3 where a, b, c are constants. And this can be extended to even fourth order equations. So you'll have an a4x here, and then you'll have y1, y2, y3, y4 here. And here you will have another term dy4. So we don't need to define every order because we can clearly see what the form will be no matter what order it is. And now let's look at a problem. So in a lot of these problems, all the fundamental solutions will be given to us because it's a lot of work to find the solutions for a cubic equation, which is what the auxiliary equation will be in this case. So the main test here will be that if the fundamental solutions and the particular solutions are given to us, and do we know what to do with that? So that will be the main idea. So find a general solution to the homogeneous equation. So to the non-homogeneous equation. Okay. So we know the general solution will be yp. So you have 4x squared plus you have ay1. So a times 3. So let's say 3a plus y. Y1 is, no, a times y1 is 1. So this is the fundamental set of solutions. So this is y1, this is y2, this is y3. So you'll have a times 1 plus b times x So a times 1 is just a, so b times x plus c times x5. And then this will be most of the work. Find a solution that satisfies these initial conditions. So y1 is equal to 3. So let's copy this. Y is equal to y of x equals 4x squared a plus bx plus cx5. Y of x is equal to a plus b bx plus cx5. And then what did we have for the particular? Okay, we had a 4x squared for the particular solution. And the conditions are y1 is 3, y prime 1 is 2, y double prime 1 is negative 52. So 4x squared. So we had y1 is equal to 3, y prime 1 is equal to 2, and y double prime 1 equals negative 52. Okay, so let's take the derivatives. So when we take the derivative of this equation, we will get y prime x is equal to 8x. Now a is a constant, so its derivative is 0. Derivative of bx is b. And derivative of cx5 will be 5cx4. Okay, and now let's take the second derivative. Okay, so that'd be 8. Derivative of b is 0. And derivative of 5cx4 would be 5. 5 times 4 is 20. So 20 c 8 plus 20 c x cube. Okay, so now this is the easiest condition. Y double prime 1 is equal to negative 52. Let's do that. So y double prime at 1 would be 8 plus 20c, x cube will be 1 cube, and that's equal to negative 52. So from here, 20c would be, so you subtract the 8, be negative 60. 20c would be negative 60. So c would be negative 3. Okay, so now let's return to this one. The first derivative. So y prime at 1 is 2. So y prime at 1, the x would be 1, so 8. And c is negative 3. So 5 times negative 3 would be negative 15. And 8 plus b minus 15. And x is 1. So this goes away. So that is equal to y prime 1 was 2. Okay, so from here 8 minus 15 is negative 7, and that adds on here. So 7 plus 2 is 9. So b is 9. B is 9. And now we come to the first one, this one. So y at 1 is what we need. So 4x squared would just be 4. Okay, and this is just going to be b. And b was 9, so this is 9. And c was negative 3. Negative 3, and x is 1. And we're given that y of 1 is 3. So from here, a will be 9 minus 3 is 6. 6 plus 4 is 10. You subtract here, a will be negative 7. And therefore, we have all the constants now in this. A is negative 7. B is 9. And C is negative 3. Okay, so that's our final answer. 4x squared minus 7 plus 9x minus 3x5. Four x squared minus 7 plus 9x minus 3x5. Okay.